Address? What? No. Oh, because it's a reference. Whoops. Let's not do that. I think we can just do that. Yeah. As long as it's just... Cool. So we have our map of cell groups. We have our array of cell edges. And our array of points, which we are then going to hand pointers out instead of indices like we were doing before. We kind of got ahead of ourselves. My partner, when he wrote this, was thinking about serialization quite a bit, and you can't serialize a pointer, but you can serialize indices. Thing is, we were doing a lot of extra work to make indices a thing, when, as it turns out, it was a lot of extra work for something that I think we can post-process even easier. We'll see. Okay, so, I would totally go to a coffee shop and order in Latin if I could. Not that I could speak it at all, but it would be really freaking cool. I love Latin. Is it even Latin? I think it's Latin. Gregorian chants. Ooh, those are such beautiful things. And maybe after this OST is done, ooh, which will be soon, maybe I'll go to some Gregorian chanting. No, maybe not. I don't think so. It's beautiful, but it's also, I don't know, that might be a little distracting. Okay, cell systems. Doing work. Oh my god, look at all this commented code. Ah. I love all the stuff that I have included at the top that I might not need anymore. We'll see. So, step one is cell edges, right? We can keep this here. Now, cell edges are going to work a lot differently. So actually, let's start generating things, and then we'll fill in constructors and things as we see fit. Because that's the other part of this, is we need to figure out what our constructors need to look like so that we can do things with our cells. So we'll say create, or actually, how will we do this? How will we do this? So we have a cell system that exists. And when you say find a cell or find a point, and that point doesn't exist, we should probably generate it. But we don't want to generate it on the spot either. How do we do this? Alright. Basic cell system stuff should say, at bare minimum, when we create the cell system, we should be able to tell it generate X, like generate this area. So let's say create cell group, and we'll have to give it, the cell system will need to know what our current resolution is, right? So it also needs to know, group size would be a nice thing to know. Yeah, that would be a really nice thing to have in mind. Integer 2D, right? Yeah, that's a C4 struct, so I need to pull it out of there, and we'll just call this cell group size. So we've got the group size, we've got resolution. Is there anything else? Not really. What is resolution for? So resolution will tell us just how many... Ooh, actually, come to think of it, I don't think... Do I need resolution? So the idea is that a cell along one edge is broken up into... Or a cell group, sorry. A cell group is broken up into a certain resolution of cells. And the reason I'd hang on to that is whenever I create a new cell group, I want all the resolutions to match. I never want to create an offset cell group or cell, because then the edges won't line up correctly, and that'll completely screw with this system, because the system is assuming a grid of certain size. So we want to hang on to resolution as well. Alright, so on initialization, we're going to, we're going to need some kind of like create cell function, or cell group function, and we'll want to give it a center more than anything else, or like an upper left. Yeah, let's say an upper left, and we'll also want what else will we want? Obviously we need to pass it the size. Although, yeah, we'll want to, well, so that's not something we should be taking in, though, every time. That's really all I can think of. Actually, we'll want to pass it our current array of vertices. And I'm not going to make that constant because we might need to change it, obviously. It shouldn't be removing, but we should be adding new vertices to it. So that's definitely important. And then we'll pass our cell edges to it as well, our array of cell edges, just so it also has a group that it can, oops, that's not C4 namespace. That's our namespace. Cell edges, there we go. Anything else? Not really. And when we create a cell group, these actually aren't cell group. You are actually the one that should be getting these as part of your constructor, probably. I say constructor, I'm not sure if that's exactly the case, but it should be. Why don't I just make cell groups of the same length and width? I do. I should. They should all be the same length and width. I don't see why they would be anything else. So there's our cell group constructor. Oh, let's get some background music back in here. Child of Light is such a lovely, wonderful thing. Let's see, what else do we have here? And I'm really sad, I've been fighting a lot with, I accidentally have been playing a lot of soundtracks that the owners are proactive on YouTube and Twitch and keep trying to mute the audio in various sections of my videos because of it. So I have to be a little careful about what I play. I unfortunately can't just like break out and start playing everything that I hope to. Ooh, here we go. Here's some background music I absolutely adore. Although I might have to turn it down. I'll leave it up for a moment. There we go. Alright, have I ever released a game on Steam? No. No, I have not. Not yet. This would be a first, and if I could manage it, I would be so incredibly happy. So incredibly happy. We'll see. Okay, so we have our upper left, because that is something that's going to have to go into a new cell group that the cell system isn't going to know. It's just going to say, well, one should exist somewhere around here, right? But it's not going to know the actual cell group. See, cell group exists. That'll have to fill itself in. A cell edge and cell. These look fine. So cell should need to take in either a range of 0.2Ds or so my only thought is I don't like creating ranges because it seems like a little overkill. Just like a min and a max or something like that. Also, This should be constant, so I actually shouldn't need this inside every cell edge. Okay, so, yeah, we'll call this min, and then we'll just take in our float width. I'll call it size, because I know everything right now is just going to be standard sized. So, size is fine. I'll try and think of any other information that might need to get passed in. But I'm honestly not certain. C4 point 2D array, point 2D array reference. Yeah. Verts C4 array point 2D, not point 2D. Cell edge. So we're passing these in. Edges. Let's see. The edge list. I'll call it the edge list and the vert list, just so it's a little more obvious where these are coming from. But the big thing here is I'm passing all this information in so that the system can right now jump in and say, this cell is smart enough to look in, grab the vertices it needs, create the new ones it needs, and then go back to its original state and have all the information it needs. Cells will also need their biome type. And they'll also need that elevation. That elevation. And see, now that I'm going through and doing this all myself, I can actually make this really pretty. And we can make sure we do this right, instead of the way I was doing it, or the way it was being done before, kind of ugly and eh. And if you have any questions about any decisions I'm making, or specifically anything I'm doing in this rewrite, please let me know. I'm really always happy to answer questions, whether it's about my style or what I'm doing, because it helps me reevaluate the parts of the system that may not make sense to an outsider, because maybe I'm doing something in a crazy way that you aren't expecting. So it's always kind of helpful to know what you guys think. Let's see here. When you create an edge, I think this isn't complete, but a start point end, and then let's see. The way I was creating them before. Cell pointer C1. Actually, I'll just call this V2, V1, cell pointer C2. Cool. Oh, is this a structure I like? Yes, this looks like a structure I can get used to. I would be really happy if this were how everything looked. Oh, that would be gorgeous. Alright, cell edge. Get this. I'm just going to move all my commenting back to the top. Just so I can find things, and they will be where I expect them to be. It goes cell edge, cell group. Okay. 1, 2, 1, 2, 1, 2. Okay, cool. Cell edge. Actually, no. We'll start with system, and we'll go outwards. So cell system. When you create a cell system, where is the part that will create the cell system? Probably in the game world, that old build terrain function call. This is the first step in the whole entire process. This is what kicks the whole thing off. You can see here's the terrain generation create cell system, and you can see that this still exists. Let's think and work our way through this. Everything's coming in sizes. Good. This range... Yeah, this should be fine. We'll call this something like create initial cell system, maybe? Or we'll find a new way to name this just so it works better, because it's not creating the entire thing, right? You can never create the entire cell system, not without running out of RAM, which, by the way, I've done that before. It is hilarious. Don't actually do it. If you keep writing to RAM and you run out of RAM, your operating system is smart enough in some cases to start writing to the hard drive. If you keep writing on the hard drive long enough, as it turns out, Windows, I think Vista, was not smart enough to stop you from writing over valid parts of your hard drive, including the boot sector, at which point you kind of borked your own computer. I did it once. It was hilarious. Not really. I just felt dumb at the end of it all, actually. Okay, so we're going to call create cell system. That's going to come in here. We create the new cell system. And all this, like, resolution stuff, this needs to actually find its way. So the resolution needs to find its way into the cell system. That's the first big thing. Also, what the cell group size is also needs to find its way in. Group size, I think, is going to end up being the constant. Yeah. Yeah, Vista was a bit of a mess. Which, it kind of says something that so many users are still using Windows 7 after 8 has been out for a long time. So right now, let's just say that a cell group is 2 by 2. So 2 actual units like that. That would be our group size. So resolution and cell group size are 2 things going into our cell system. Cell system. Resolution, float res, C4 integer 2D. There we go. Group size. Delm Lord, yes, this is one of my favorite parts of the game. Was the music, honestly. It was just gorgeous. They did a really good job with reusing the guy that they used from Bastion, Logan, but they did it in such a way that it didn't have the same narrative feel in it. Let's see here. Resolution, res, and then cell group size and group size are going to get worked off of one another. We're going to copy those details over. Anything else that needs to live in cell system right now? Not that I know of. Okay, so you create the cell system in the terrain generator. And in fact, just to put these in order of use case, you can see, I'll pull Game World out here too. So it goes Game World, World Generator, Terrain Generation. This is something that I do because I'm very picky about what lives in my IDE at any given time. So I'm probably going to close Game World since it's a little, well, we'll leave it up for now. It's kind of overkill, but we'll leave it. Alright, But as you can see, the call system goes back, and so I can follow it very easily, which is really nice. So we create the cell system, and then we say, cell system, create a cell group for me. And what we need to do is we take the range that we are currently using, and we're going to have to wrestle it into our... Actually, no, we don't need to wrestle much of anything. Let's see here. We have a cell group size. And so all I think we need to do is wrestle the range into the group size and go from there. Now, I'm actually going to pull this out. If only because this is going to be a constant. When you first start the game, we're always going to create a cell system of a certain size, and if you're loading a game, we're actually going to create the cell system and then immediately load, so we don't care about what that range is, which is a good reason in my mind, or a good defense at bare minimum, to pulling that out. So, the create cell system, we still need to pass it the resolution. But we don't need to pass it the same stuff we did before. Yeah, looks good. Okay, doing well so far. Now, create the cell group. For now, we're going to start with just the one single cell, who, if we want to center it on 0, 0... Ooh, is that a... Let's not center it on 0, 0. Let's put... crap. So I'm gonna have the grid. Yeah, you know what? Screw it. The grid. How do I do this? How do I want to do this? So there's two ways I can do this. One is I can use 0, 0 as the center and have a grid around it. The other thing I can do is I can have a grid centered on 0, 0, and then work the grid kind of around it like that, and that would be similar, but I'd be changing where those come from, and I'm not sure. Forget it. I'll just use a standard grid, and I'll just create 4 to start with. So, upper left, we're going to start with the cell group size. Let's see. Integer 2D cell group size.x cell group size.y. We'll start with our usual -x and y, followed by x and y, followed by x and -y, and then followed by -x, -y. This doesn't look right. -xy, xy. Oh, this should be positive x here. There we go. Ah, coffee. Woo! It's got some kick to it. Not really. It just actually started to go down the wrong pipe. Sorry, guys. Don't mean to make a ton of noise there. All this resolution code is going to end up somewhere else. For now, we should be fine. But, create cell group. Let's see here. So this should call immediately down into our cell system. Cell system. Create cell group. Yeah, just create cell group and it takes an int 2D. Where the heck is that? I wonder why this isn't... Oh, I see the problem. You require a semicolon on the end, while you are a cell system and require little more than that. Ba-da-bum-bum. Alright, so we have our cell group. And when we say to create a cell group, let's see. We have to very heavily consult what our architecture should look like. And in fact, this is... yeah, this is to the point where I think I can nuke all this just to make it easier for me to find what I'm hunting for. So here's a cell group. And we are going to say we want a new cell group. And we're going to have to hand it the vertices. Oh, it's the vertex array. Okay, vertex array. Actually, I'm just going to call it vertex array. Why not? Sure. And we have our edge array. Is there anything else? Honestly, we should be passing the cell group its upper left at bare minimum. Integer 2D upper left. And also we'll want to pass it its size. Int size. Also, this should be... Let's not make this too crazy, right? Let's make life easy for ourselves. And make sure that all the stuff we're doing is not too overly complex. So I'm swapping this from an int 2D just to a standard int, because I don't want my cell groups to be different widths and lengths and crazy stuff. Don't care for it. Cave Story was not made in GameMaker. Cave Story was made very much by hand. I actually met the guys who worked on the various art and programming behind Cave Story, and holy heck, it was... they are really cool guys. The problem is one of them only... his English was not all that great, so speaking to the artist was difficult. I think it was the artist I had problems speaking with, but the programmer was very, very well spoken in English. But yeah, it was nice to have a quick chat with them, especially considering like how much they did with how little they had to work with was fantastic. I'm always envious of people who can do crazy 2D sprite work like those two. Okay, so we have a new cell group. We hand it the vertex array, we hand it the edge array. We also have to hand it our upper left, which is just going to pass straight through. And then the size is coming through as well. So cell group size. Cell group pointer. The new group is going to be this. And then what we're going to do is we're going to go to the cell map, or the cell, did I just call it? Cell groups. Okay, cell groups. And we're going to insert the element new group. You should be an integer. And a little more simplification coming through here. Nope. You. Int. Not an int reference either, just an int. So, Poison Spider, it takes some time to get good at this. But if this is something you enjoy, I would highly recommend getting into it. And just start small and work your way up. It's the same thing I tell everyone, whether you're a university student, a high school student, doesn't matter. Whatever you know, take what you know, start a project that forces you to learn something new, and then make that project. Whether what that new thing is how to put an image on the screen, or whether it's how to write this crazy AI, it is always the way to go, is try to create a project who has as few unknowns as possible, And that's really the way to go with it. I started... I want to say... I mean, my first game was C# and X and A, and I think I did it across a couple months. And that was with me learning way too much stuff at once, right? I was trying to learn C#, I was trying to learn game design. And honestly, it was a nightmare, but I had, luckily, a grade that I couldn't afford to fail. It was kind of my big thing at the time. Does not define this operator or conversion to a type. What? Int group size. What are you complaining about? Cannot convert. Oh. That's fine. Const int. And we'll make this, since we know it's a constant, let's just do that. We'll just put the k in front of it, just so we know. Also, let's think a whole bunch about how we're going to do this before we dive in. Because we could do this the right way, and we can do this a very wrong way as well if we're not careful. So let's say for y equals 0, y equals -1. Do I want to generate that much terrain? That seems like that would be a lot of terrain. Well, this is a good way to test it. Y is less than 2, plus I, y. For int x equals -1, x is less than 2, plus x. Bam! And we are going to instead x and y. Once again, all this simplification we're doing, every step of the way, taking all the stuff that we used to have and compressing it down into the simplest thing until we'll just get a little bit of code in the right place, and all of this simplification will kind of expand into something more powerful. We'll be doing a lot more with less, which is fantastic. That's what we want to be doing. This should be fine. World generation. Okay, so this jumps into our create cell group. Create cell group is going to pass this information into the cell group constructor, which I don't think exists yet. No, it doesn't. Definitely doesn't, because no code for the cell group exists yet. Why doesn't anyone just make a console game? Because you require a dev kit, and in most cases, getting your hands on a dev kit is difficult unless you're a big publisher or a big name developer. And most streamers you see, except for obviously like the Wolfire guys and the Pocket Watch guy, most everyone else you see, myself included, is too small fry to ever get a dev kit without putting a lot of money out in the first place. It would be cool. And luckily with the Xbox One and PS4 being so close to x86 architecture, it shouldn't be hard to port a game from PC to either of those consoles. But really, that's why you don't see anyone making console games right out the front door. Oh, whoops. Something you could, yeah, compile and play inside a console, then yeah, that... I don't know. It's simple enough. It wouldn't be hard. Okay. Cell group. Let's see here. So our group range is going to be so our upper left, we have to do the conversion. From what I'm going to be terming the grid coordinates, and we need to spread that out to the actual world coordinates. And Chocmaw, for all that talk of wow, I totally lost my train of thought. For all the talk of freaking out, I haven't yet. I'm waiting for it, but we'll see if that kicks in later or something. Upper left dot y plus size times size. Should this be... no, not size, plus 1. There we go. I'm waiting for it, though. Okay. The group range is equal to this range. Open, open, shut. Open, open, shut. Open, shut. Shut, shut. Really? What am I... oh, one too many? No, that's not right. The point 2D should close here, and then the whole thing should close here. Why are you complaining? Integer 2D, not point 2D, so which means copy, a paste, a done. Is not a member of cell group. Okay, we'll fix that in a moment. So okay, group range is set up, and the other thing is that our cell array this is going to be a new cell array of size what? Oof, this will be size times size. Right? Int size. No, that's not right. That's not right at all. Because size is one thing. Resolution is another. And it should actually be size times resolution. The other thing is that at this point we should actually probably have resolution boiled down to an integer. We shouldn't really be worrying about the actual resolution, and we should be worrying more about the number of cells that generates. No. Size times resolution. So if it's a 1 by 1 and then we convert that by 4, it would be 1 by 1 by 4. That wouldn't be right. Times, okay, it would be size times resolution times size times resolution. Holy heck. Let's just simplify this just so I understand what the heck I'm doing to myself here. But, oof. No default constructor exists for class cell. Details. Alright, resolution needs to go into our cell group. And honestly, this should get converted over. Couldn't you just do size times resolution times 2? No. No, I couldn't. I could square it. That would work. Yeah. You got it, Novio. Is that right? Novio? That seems right. Alright. Glad someone here's paying attention and keeping me in check. Because it definitely isn't me sometimes. C4 pow. Why not, right? We'll do that and put it to 2 and they're done. Ta-da! Oh, except that this... Ooh, yeah, no, let's leave it as is. If only because the power function outputs floats, and we want to make sure that everything stays as expected. It's not using an integer power function, it's using a floating point, and we don't want to muck with that. Okay. Cell system, this should be an integer, and that should be fine. Cell group. Senjai, unfortunately, I'm in the middle of a big rewrite, so just kind of dumping out the game, it's not really going to start up right now. It's got some 1, 2, 3, 4. 1, 2, 3, 4, 5. Oh, whoop. You have an issue as well. The resolution needs to end up in here. Yeah. Resolution, okay. We should be down to, yeah, just the one expected error that there's no default constructor available for cell, which is fine. It's interesting that it wants a default constructor, but we can create one for it. I'm actually kind of confused as to why it would want a default constructor. I wouldn't imagine that it would call the default constructor on every single one of these. Unless... no, I don't think I can hand it. I don't know, it's just bizarre, because I would think this new call would just set aside the space and not call a default constructor. Just to shut the compiler up, though. That the caret binding is stronger than the multiplication. Yes, except that you've put s times r inside parentheses, so s times r would go first. You don't have a cell int. Why would I need an int? I'm not passing it an integer, I'm creating an array here, is the thing. Maybe because this doesn't have... That would be bizarre, though, if that's the way it wanted to play. Yeah, no, that can't be right. I don't know. It's so weird. Oh, and then we're back to get key is not a member of cell group. That's something we have to remedy as well. Cell group has this... Oh, not get key type. What? Get key type? That's not right, is it? No, it should just get key, not type. Does not define this operator or conversion that is acceptable for the predefined operator. Binary that does not define this operator. So what it's complaining about, I assume, is that point2d doesn't have a less than operator. And without a less than operator, it also doesn't have an implicit equals operator. If this key is less than the other key... Yeah, because it looks like it's inserting them into a tree. Okay. So we've got two things we can do. One would be to... One, we could stop using point2d as this, right? We could try and just hash our point2d into a system. Oh, hey, somebody wants to schedule a phone interview with me. Cool. I like phone interviews. Those are good. I am very happy that people want to do phone interviews with me. Okay. Sorry, getting distracted. I see the emails come in and my brain goes, ooh, what's that? Shiny. Let's see here. So let's see. Maybe we can find a hash function. Specifically, we might be able to find some way to... Let's see. I thought there was like a static hash function somewhere in here. The other thing we could do is we could just make our own hash function. Static hash. Compile time. Oh, that's a compile time hash, though. Oh, look at that sucker. That's cool, but not what we want. It's interesting, but not what I want. Let's see here. What's a good way to hash this out? So, the most obvious thing I can think of is that we could do some crazy spatial type hashing. That might be overkill, though. Oh god, that's a white paper I don't want to dig through. As interesting as it looks, I don't have the time right now. Although I'm going to bookmark that for later. Let's see. What can we do here to make ourselves a nice... So I'm looking at Stack Overflow. Sorry, I don't mean to just stare off into space while I figure this out. So it looks like people, granted these look like they're C# get hash functions. But it should be in our favor if we do something like use an integer instead of the standard stuff to hash. And what we can do is we can just write a get hash code function like this. And if we do something like this, well, except this is bad because obviously this is a communicative operator, so we don't want to be using that. Da-dum-dum-dum-dum. System double has a nice implementation. I kind of like this. This should be an interesting way to do it. You essentially use you use a hash that transforms as it goes. Something like a CRC hash is something you could do really easily through this method, maybe. Of course, a CRC hash expects more information than just 2 floating point numbers. So, man. There's a lot of, like, crazy stuff in here that I'm not really sure I care about. Fast. And we want this to be relatively quick as well, because if this takes too long, then we start getting into a weird space where we don't really want it to spend way too much time doing some of this stuff. And some of this code I really don't understand. Like, why would people do things that are this over the top? Let's see, some kind of hash table. I could use the memory address of the cell as a hash key. So the cell group, I could use the memory address. The only thing I would worry about in that case is that this key is going to change and be very difficult to pin down between runs. So the only reason you don't want to use something like a memory address as a hash key is because when you go out and serialize something, that key is going to get serialized alongside it, and then when you load everything back in, that's going to change. And that's kind of scary. I'd be a lot happier with something that gets calculated instead of something that relies upon memory to be in a certain way. And that's why I kind of keep looking up everyone else's, like, how do you do this? Because it would be nice if I could just get a good, like, spatial hashing algorithm or some kind of geometric hashing, just so that the pair of points don't ever really collide. And I'm finding some people who can do this quickly. That's the other thing, too. I want this to be quick, right? I don't want to do a ton of, like... I don't want to do a ton of math just to figure out where something should exist. Ba-dum-bum-bum-bum. And of course, yes, I know, standard does have a hash thing, or a hash object, but I don't want to use that either. That's kind of the big thing that a lot of stuff is bringing up, and that I don't really care for at all. Okay, and that's overkill too, so let's go with the most appropriate thing I've seen so far, which is this kind of moving hash. I like this. That seems fitting. So our key type is now an integer. Should make this a lot easier. And what we're going to do is we're going to start with some random number. We don't care what. 17 is the random number they've got here. Just to make sure... 17, whatever. 23, and this should honestly be a different number. I don't actually know why they kept this number the same. Actually, I like powers of 2. So sue me. There we go. 2, 16, 32. Hey, hey, there we go. And since we're not using C#, we don't really care about this stuff. Yeah. Point 2D. We're just going to keep the group center. So all we have to do is say the group center.x and not .get hash code, but actually just this number. And then group center.y. That should be nice and simple. Nice and simple. And now we need to make sure that our cell group is actually calculating this number. So, not just the group range, but we need our... I'm just gonna name these things. They don't... I always do this. I have a lot of redundant names in here. And it really is just... It's overkill. Range is this. And then our center... is going to be our, let's see here. Gomez, I don't know if you're talking about, or if you're talking to me, or if you guys are talking to anyone else in the channel. And when you're asking if this has a lot of collisions or not, because the hash is what we call a roaming hash, it's not going to collide with a lot of stuff. Specifically because if you look at how it works, it starts with a value inside it. And then what it does is it takes this value and not only does multiplication to it, but also modifies the value with each part of the new value. So this keeps all of the parts separate, essentially, which is nice. So, let's see here. We're finding our center so that we can use that for our hash later. Open, open, shut, shut. That should be fine. Yes, and it doesn't look like it's complaining. Good. What else do we have? Is this done and happy again? If it's happy, I will be happy. Cool. Alright, so we've got range, center, and cell. And the cell group needs to generate all the cells inside the actual cell array as well. So for int y equals 0, y is less than the size, plus y, and then int x equals 0. And for anyone who's wondering why I do this backwards, or what seems like backwards, is that if you do for y and then for x, what you end up doing is you start at y equals 0 and you read left to right, top to bottom, the same way you would for something like, I don't know, for like a book or anything else. It makes the grid read in a certain order, or I should say initialize them in a certain order that for me works out better. Cell array, and then all we have to do is say it's y times the size plus x, and that gives us the cell index that we're hunting for. And then we say this index is a... So this should give us a cell, right? We should be able to very simply just create a cell at this point. So we have to find the cell's position. We have to do some other stuff. But first, I'm going to be right back, because all this water and all this coffee I'm drinking is going right through me. And I have to use the restroom. So, for those of you who have been watching non-stop, I commend you on your endurance, but I, alas, can only endure so much. So I will be right back. If you are watching this for the first time and haven't taken a moment to kind of figure out what's going wrong, I would say hitting the follow button and checking out the YouTube channel that is in the stream description is a good way to catch up. Now, granted, it's the full streams down there. I haven't cut those down at all. So it can be a lot of content. So just deep breath, one step at a time. The other good way to kind of figure out what I'm up to, ask the kind folks in chat, who's I'm sure are more than happy to explain either what the heck they're talking about. I'm trying to figure that one out. Or you can look at the Trello link that is also in the stream description, and that will give you kind of an idea of what's up and coming. But the two big things I want to do is get this terrain rewrite done, and then I want to dive in and do some AI work. I want to create a state machine tool so I can create AI nice and easy. But before I do all that, I have to use, as the English would say, I have to use the toilet. I'll be right back. I am back. I'm refreshed. Let's get to it before the caffeine wears off. And before I start to freak out about how much code I've changed. Alright, cells. So a cell group automatically creates all the cells that it exists inside. So, let's see here. And the other thing to do, so this is where one of these optimizations that we're going to do kicks in. The big optimization here is that a cell group is going to contain all of the vertices that a cell is made up of, or that all the, sorry, let me say that again and not completely mess that up. A cell group is going to contain not just the cells, but the single geometry object that makes up that cell group. Yes, that's better. Because what that does for us is you can... Yeah, that makes sense. You can have the entire geometry get drawn at once or disregarded at once. Instead of all the little cells that we were doing before, which was hurting our frame rate like mad, we can now have as many cell groups as we had cells before. And we'll get somewhat similar, if not better, frame rates, which is kind of absurd, right? Considering before we had, what was it? It was like a 10 by 10 area? Where's the game world? Build terrain. Here it is. So our terrain was 10 by 10, so it was 100 square units, and our resolution was 4. And that needs to be an integer now. Right? Well, it doesn't say it does, but it needs to be now. You need to be an int. Drag this to the right spot. You need to be an int. Better. So, before, what was that? That was 100 square units. And then that was the 100 square units times 16 tiles per square unit. So that's 1,600 cells. So we can have, I would say, probably 1,500 cell groups and have similar, if not better, frame rates. I'm down. That would be awesome. So already, the big difference here is that we're not only doing optimizations, we're also making the whole system easier to use and easier to generate as well. So that when all is said and done, the other thing we can do is we can say generate a region, and since it's a grid, it'll be easy for us to say cut this area out and use one of these pre-made cell groups instead. And so something like a... trying to think of a good example. Like, say there's a city that's broken down and all the ruins are spread throughout multiple cells. You can create that and hand make one of those cells, and then hand that handmade cell to the random number generator, and it will put it in at interesting intervals so that you can run into ruins or handmade things that I as a designer have made, and you can run into that inside the world. Whew. Alright. So, code. Pull that out. We're back to terrain, which creates a cell group. And then the cell group creates the cells. And this is... Am I choking up? I might be. I'm also a little out of breath. I did a whole bunch of stretches right before I hopped back into stream, so I'm a little out of breath. Which is fine. Not really choking up, but just kind of... not breathing heavily, just talking between breaths. Alright. Cell. What does cell need? Cell needs... not a 0.2D. Does it? 0.2D size. So a float size and a 0.2D. Okay. So, let's just... C4, 0.2D, X and Y, and then size, which is not going to be the cell group size, is going to be the cell group size times the resolution. No, not quite. let's see. If the size is a unit and the resolution is 4, then it would be size over 4. Yes. So as the resolution goes up, these are going to get smaller. And as the size gets larger, these will get larger as well. Good. Vertex array, edges. I like how I've got like a really verbose name for one. Verts. Verts and edges. Much better. So, and the other thing we're going to have to do at the end of this whole process, right? I'm calling new here and there, and I need to make sure that I also call delete in matching places. So we're going to have to do that as we go as well, just to make sure we're not leaking memory anywhere, because that would be a mess. Verts, edges, and size. So this X and Y isn't right either. And Chakmo makes a really good point here as well. Float. We'll just make one of these a float. Well, actually, I'm going to cast them both to float just so it's obvious what's going on. But yes, that is a good thing to keep in mind, is that since these are both integers, this would come out as an integer as well, and that's not what we want. So you'll find that most game designers don't use doubles because it's more precision than we need. And it also is a lot heavier to do a process on a double. So adding 2 doubles is a lot heavier than doing like the addition of 2 floats. So unless you really need that precision, we tend to dodge doubles when we can help it. Why don't I use smart pointers? Someone else brought this up before. Smart pointers are nice, but I don't know how they're going to play with the engine's memory management. I don't know if they would call the standard new and delete stuff or what they would do. It's kind of undefined what happens to a unique pointer when you've overridden new and delete. Right? So I'm keeping away from those, as nice as that feature would be, just for now. Let's see, so cell array, we go to the right index, and we're going to fill it in with the details of this cell. So this is going to be a pointer. So this is how I expect to have to do this. Oh, also, why is this named cell array? Oh, because it is. And it's a single pointer to a cell. And if we find the offset of that, must be a modifiable L value. It is a modifiable L value. What are you talking about? Oh, it's only a modifiable L value after I do this. Cell pointer C equals, let's do this right. Yeah. Sorry, back on track. This X and Y still isn't right. We need to mark these by not only the offset, so let's see, cell position, and this needs to be the, what? We need to use the upper left times, actually we can just use the range. Range min X, because this is, nope, that's an int32. Huh. Okay, so we have our range min, and we say X times size, and then range min Y plus Y times size. There we go. I don't like doing a ton of processing in a single line if I can help it. Breaking it out into its own lines not only makes it easier to debug, but also makes life a little easier when it comes to reading the code later. Although, we should probably do this in the right order. Actually, no need to break those up. Or move them around even. Okay, so cell position is getting set. These are set. Verts, edges, all set. Cell group. Let's just make sure you have this name right. The cell group. Verts and edges. Good. Verts. Edges. Oh, I see why I named those as is there. Let's keep it consistent. I really want this code to be clean so I never have to touch it again. Good. Okay, nice and consistent. All compiles? Yes, please. The C equals line does nothing? No, the C equals line is correct. If I did something like this, let's see here. That would mean that the, something in the linker is unhappy. This would be the copy constructor getting invoked, and I need to do something like this. I guess that's a little cleaner and happier, though. Also, what is it complaining about here? The cell does not have a matching... Oh, I've got the standard default constructor, but I haven't actually written out this thing. Okay, min. So, let's see here. So, center is min plus 0.2d, size times 0.5. There we go. There's center. We also need to calculate what else. Size we actually don't care about here. Do we? Not particularly. Vert list, edge list. Okay, so we have the center, we have the minimum. We can just generate our 4 corners out of this. So vertices. Oh, but we need to make sure that these are pointers, right? So that means, actually we can still do this. I equals 0, I is less than 4, plus I. We say C4 0.2d vert position is going to be, let's see here, we're going to start with min dot x plus, let's see, if I mod 2 equals 1, then we either add size or 0. Min.y plus I over 2 is 1. I guess I should say I over 2 is greater than 1. Yeah. Because I equals to, let's see, oh, greater than 1 though. No, greater than 0. Because I equals 0 and I equals 1 are both, since this is all integer math, those will get dropped down to 0. Yeah, okay, cool. Doing this right. Just making sure. Vertices, or I guess I should say first, the vert list find element vert position if int vert index is this. If the vert index is -1, then we add the new vertex to the list. And this is code I've written before somewhere, I bet. Had some programming courses, but I never understood why pointers are used. Can someone explain? I was able to solve the problem without them so far. So, the idea of pointers is that you can... let's see here. What's the most common thing, I guess, for pointers that I can think of? So, let's see here. I'm just trying to think of a really, really good explanation here. Because the thing is, if you look at references, they tend to make up a lot of use cases for pointers. Like the most common things you can think of that you can do with a pointer, you can also do with a reference. The reason that we are handed something like a pointer is so that you can keep long-term access to a variable and then pass around. So say here, I got it. MS Paint, come here. I'm gonna do this real quick. So, say we have an object that we've created. Say, we have like a car object, right? And I don't really care what's inside this car, except that we have an object called like wheels, right? And we want to pass, or not even wheels. Let's say we have engine in the car so engine is an object, right? This is a class, and these are classes as well. But these are instances that are contained within car, right? Now, say engine is something that we want to pass to a different function. Like we have a mechanic class that can look at the engine. Or we want to just print information about this engine. In some cases, you could pass the entire car, but you don't want to pass the entire car because that's more information than you want to make available. So what you can do is, you can grab the information that lives engine as a pointer and pass it to a function. So now we have some function that's like examine engine. And now you can pass this pointer. Ooh, that was messy. You can pass that pointer into this function. You don't have to pass the entire object. And the other thing is that when you pass in one object like this, one part of it, you're not giving access to the other things that are in this car. And also you can very easily say, well, this is this is a constant, so that they can't change the engine. Or, let's see, what else? I'm trying to think of other good use cases. I guess the other big thing is that, can I clear this easily? Kind of. The other big thing, and here's the use case you'll see a lot in Windows programming. Different libraries and DLLs have different memory spaces. So, whoops, when did that happen? So when I have a game, this is the memory space allocated to my game. And then say I have like, I don't know, a QuickTime. Ugh, I hate it, but I'll use it as an example. Say there's a QuickTime library. This QuickTime library, if it's in a DLL, is going to have its own memory space. So if it allocates something in this memory space, it's not going to be possible for my game to see what exists inside this memory space without it passing pointers back and forth between the two memory spaces. What you see in Windows a lot is that your operating system will sit on this level and have its own set of memory, and when your game says, I need a DirectX object, what it's going to do is it's going to pass it an empty double pointer, or I guess, yeah, it'll pass it an empty double pointer, and it'll pass that into Windows, Windows will then say, oh cool, you've given me a double pointer. I'm going to use that double pointer to fill the information in. So it's going to call new on some object, and it's going to fill in that pointer. And then when you call like release, it's going to call back into Windows, and Windows says, okay, you're done with that object. I'm going to then call delete on it. And so it's a way to pass around memory, not just between DLLs, but to also signal who should own what bits of memory. It's a very interesting case, and it's something you can spend a lot of time getting lost in if you're not careful, especially when it comes to multiple DLLs and who owns what. It gets a little bit crazy. They do have a lot of really good uses, though. And outside of using references, they are essentially the next best way to pass around chunks of information without causing copy constructors to go off. Because keep in mind, a copy constructor takes this and says, okay, I'm going to allocate something new on the stack, and then I'm going to copy every detail. If it's a shallow copy, you might get away with stuff, but if it's a deep copy, every parameter inside is going to get copied, and that's going to take a lot of time. I hope that was... Pointers are kind of a big subject, and honestly it took me a long time to not just understand their use cases, but also to understand kind of why we go about using them, and some of that is implicit in my head, and I don't really think about it sometimes, and it's something I need to do a little more often, is look at the code I'm writing and say, okay, does this need to be a pointer? Can this be a reference? Does it need to be this? Can it be that instead? Yeah, those paint skills. Sexy, huh? Music, are you over? You're over. Sad. I'm gonna go for Bastion next, because I'm just in a Supergiant Games mood, apparently.
Listen.
And I'm sure I missed several use cases, right? That's not obviously the only use case. There's a lot of use cases for it. But that's just kind of the big use case that I'm going for. Or one of them.
Not having to watch my step up.
Oop. There we go. Got our music, got our code. Let's get back to work. Yeah, let me know if that wasn't that great of an explanation. I kind of know it wasn't. My mind is unfortunately somewhere else as I try and do this rewrite. But hopefully it was a little bit elucidating. Is that the right word? Elucidating? Elucidating. Yeah. Make something clear or explain. Yes. Cool. Alright. Cell fills in its own details. It finds vertices. If vertices don't exist, it then fills itself in. This is actually the point where I need some of that code that I had before. Let's clear and close some of this stuff up so that I can game code. Let's see, what file was it in? It was probably in the cell file where I nuked all this stuff. Get area, find neighbors, generate mesh. While all of this is good stuff, I actually don't see the code for... Oh, I bet it was in the terrain generation. We might actually be able to remove a lot of stuff. Maybe even this terrain generation file can go right out the window if it doesn't serve much of a purpose anymore. We'll see if it continues to, but I have a feeling that a lot of the code that we wrote last time might actually end up in here. Done. And, like, completely written as is. Which would be nice. I also like these kind of living in their own little sets of data. That actually cleans up this a little bit more. So we can do just min and then min.y plus size. And then we do min.x plus size and min.y plus size. And of course I hit F1 instead of the button I meant to press. Min.x plus size. This makes life a lot easier. If it contains cell vertices I, there we go, much better, much cleaner. I like this more, even though it uses up more lines. It also is easier to read, a little easier on the eyes, I should say. And is there a way to change the color scheme of this? Because this is really, it's really crazy to switch back and forth. But it does not look like, it doesn't look like there's a quick and easy way to change the details of this. More commands, ugh, and it uses ribbon. Ugh. Colors, ooh, colors. Can I make the normal background like black? No, that doesn't look great or nice at all. Fine, we'll leave it at automatic. Ugh. Okay, whatever. We'll figure this out. Don't use ribbons. Okay. What other code did we want from in here? Because this create cell stuff is nice. I like all the code I wrote for this. This was clean, good code that I wrote last time. Obviously, vertices I is going to be equal to the vert list plus I, or plus, plus the vert index. That gives us a pointer. We're now hanging on to the right pointers for vertices. Paste. Bam. Here's our edges. We only have 4 of them. And once again, this uses integers instead of pointers. Ooh, I just thought of one more thing. Without pointers, you can't do things like dynamic arrays. That's big. That's really big. Just kind of saying. Why not just make every variable public? Ugh. So there's an idea of accessibility that allows you to kind of block off access to certain functions. For example, say these cells, they all have these private variables because we don't want every other class to have access to things. And these are fundamentals of C++, and actually any language is going to have private and public stuff. But the big reason you really don't want everything to be public is that you want to signal intention with your code, and you also don't want to allow other people who are writing into your code to be able to modify the objects that you don't want them to have access to. So for example, the game should not be able to modify the internals of class. They should only be able to, you can write some getters and allow them specific access to only certain things, but it won't create what's kind of called spaghetti code, where the code just kind of attaches to itself in a mishmash of ways. That's kind of one of the biggest reasons. Alright, let's see here. So we've got our pointers to edges already. I think somewhere in here, okay, it's our edge list. Our edge list, we should be able to find an edge who matches certain things. It's not good practice to make things public like that. It really, really isn't. You should not get into that practice. If you're ever going to write code for anybody aside from yourself, it's just don't do it. The funny thing is, in C++, there's a really freaking easy way around it. And it's called converting to a void pointer and then doing pointer arithmetic. But I'm not going to go into that, nor show you guys how to do that, because that's a bad thing to do. You only use that kind of stuff when you're getting access to things you probably shouldn't have access to. And in that case, I don't want to teach you guys that habit. Okay, so we've got... Oof. So let's think about this. We've got all our vertices in place. We now need to check how to get access to all these cells. Specifically, we probably want some kind of helper function in here that essentially allows us to find edge by vertices. Point2D pointer v1, point2D pointer v2, and of course and I'm going to make this constant just to make my point here about good places to use things like this. Let's see here, return, cell edge pointer. There we go. And this is going to be a little ugly, because I'm going to have to iterate through all of these for now. I'm going to have to think of a better way to do this eventually, but for now, it's kind of the best I can do. The edge list, element count. Let's see here. So we're going to pull out each and every edge. Ugh. So we look at the edge, and what we're going to say is if the edge, if it contains vertices v1 and v2, then we return that edge. And if we go through all of them without finding it, we're going to return a null pointer. So let's see here. We need to, of course, write this function, because nothing exists anymore. Or very little, I should say, exists. If you want a very flexible language, look into JavaScript. That stuff is really interesting. I've seen people do some really crazy stuff with self-modifying classes, and it's just kind of a crazy thing that happens in some of these cases. Cell edge, yes. Some of the most interesting stuff are people who write programs that modify themselves, and so you get programs that unfold themselves essentially into this, like, they go from being a couple thousand bytes into these like gorgeous 3D rendered scene, like pre-recorded scenes from this tiny little thing, because it's some like incredibly, complex thing that gets specifically written to modify its own contents and do that kind of unwrapping on itself. It's absurd. Let's see, each cell. Okay, so vertices 0 equals v1, and vertices 1 equals v2, or vertices 0 equals v2, and vertices 1 equals v1. I have not written self-replicating stuff. No. That's beyond most of my programming skills, honestly. It's just more than I ever care to go for. Did I know how to program when I started college? Vaguely. Very, very vaguely. I had a kind of half-assed idea of how programming worked, but it was never anything terribly serious. It wasn't until I got into community college and started writing basic programs in C that my understanding filled out beyond just, oh look, here's how like a couple basic things work. Oh god, the Girl Scout cookies. The Girl Scouts are out again in force selling cookies. That's frightening. I think I've still got a box of Thin Mints sitting around. Oh well. Contains vertices is written. The dump. So this should... Let's see here. So now we need to be able to find... We have this find edge by vertices helper function. So we're going to sell edge pointer. Where am I? I'm in Santa Clara, California. Apparently in Palo Alto is where she is right now, where they're selling the cookies outside of her store. Yeah, those things are crack. Let's see here. So for each edge, so that would be vertices I and vertices I plus 1. Oh wait, no, vertices is... Yeah, vertices is right. I plus 1 mod 4. So we're going to find the edge based on these vertices. And I'm curious why it's complaining. Too few arguments in function call. Oh, we have to hand it the edge list, of course. Of course. And then we say, well, if the edge is a null pointer, which it can be, then the edge index, or I guess I should just say the edge, is going to be a new cell edge whose internals are vertices I and vertices I plus 1 mod 4 close. And that also was an incorrect delete on my part. Cool. Point 2D. I feel like there's something else I'm missing. Cell 1 and cell 2. So when's the game going to be finished? I have no idea. No clue whatsoever. I really wish I knew that, but I am so early in development that it's not even something I can even begin to guess at. Let's see. Is it a this pointer that I'm using? Yes, it is. It is a this pointer and a null pointer. And then we need to go into the edge list, add an element, the new edge. If it's not a null pointer, can I show you guys what I have so far? No. Unfortunately, I'm in the middle of a giant rewrite. I'm not doing all this from scratch. I am using a pre-made game engine called the C4 engine, which you can find the details of in the description below. I'm kind of figuring out where on my camera you guys can see things. It's like, okay, from here to here. Cool. Oh, poor dog. He's in the dark. Turn that light on for him. Yeah, can't show you guys what I have so far, but I'm going to soon, hopefully, have this terrain system rewritten, and when it's rewritten, then I can start showing you guys what I got. But this is going to take a little bit more time, which is unfortunately going to be unhappy because the girlfriend's going to get home and be like, what are you doing still programming? Started late. Had a big task. Not done yet. Okay, so if the edge is a null pointer, else, we need to make sure that the edge's second cell is not filled. So, let's see here. Set neighbor cell. Trying to think of a better way to do this. I think the only other way to do this well is to say this is a friend class of cell. Just so cell can reach in and dig around in the contents of a cell edge. Is that the way I want to do this, though? Is it? Or do I want to just write a standard getter and setter? I think I'm just going to write a standard getter and setter. Cell pointer get cell index return cells index, and then the other thing is void set cell idx and cell pointer, and we're just going to say cells index is C. Now we're not putting any guards on this, and it's because I don't assume I'm going to need guards. Granted, I could be really dumb and be shooting myself in the foot right now, but the hope is that I'm not. So we are going to put a quick check in here and say if the edge get cell 1 is not a null pointer, which we need to make sure to initialize these to null pointers when we finally get around to writing the cell edge. Let's see here, initialize cells in array to null pointer. There we go. If it's not equal to the null pointer, the engine report multiple. Actually, I've written this before. I know I've written this before. Where was that? More than 2 cells are attempting to use a single edge. There we go. Copy. Paste. And okay, report error. So that'll show up in my error logs, and I honestly, did I have any? No, I don't have any other support for changing that, which is fine. Edge set cell 1 to this. Cool. We've got ourself. Oh, we have some errors because we haven't finished all this stuff. Dump. Cool. That should be done. And then finally, edge indices, or I guess I just, what did I name them? Cell edge, just edges. Edges I equals edge. Kind of confusing, if only because edges and edge are so close. I'm actually going to move this down to E, simply because I don't want those being so similar to each other. And it's kind of obvious that E is an edge still, so it's not the end of the world. Cannot convert argument 1 from a cell edge pointer to a cell edge. What are you trying to do? Edges. That's fine. We'll just make it a pointer of cell edges. Is that okay? Is that really okay, though? Let's think about this for a sec. Do I really want this to be edge pointers? Because it would be nice, I think, if I could leave this as just cell edges. Because then it's creating double pointers inside the array if I don't do this. Problem being... Let's try and leave it standard. Try. We'll see what we can do about this. So this is going to complain. No, not you. you. Ah, gosh darn it. Cell edge. Where the heck is it doing that? New cell edge. Here. There we go. So what it's going to do, if it can't find it and it is returning a null pointer, what we should do is go into the edge list and say e equals edge list add element. And then we should just pass this mess in. And then we can just, after we've done that, we can just say edge list dot get, nope, e equals edge list dot get element count -1. That should do it. Oh, except plus. Otherwise it won't give us a pointer. We want to make sure it gives us a pointer. Alright, unresolved external symbol, cell edge. Specifically, it's complaining that it doesn't have this, which I could swear, I'm fairly certain I've written this already. Cell group, cell system, I guess I haven't. Cell group, cell system. Where'd the cell edge stuff go? Oh, here it is. Apparently I haven't. Whoops. Alright, cell edge, let's fill you in. Specifically when it comes to vertices, 0 is v1. Actually, let's see if I can do it this way. Vertices, v1, v2. Man, I was hoping I could fill in the array using, not a default constructor, it's a, oh, there's a word for it, and I'm failing. Oh, gosh darn it. An initializer list. Yes! Gomez has it. Array initializer. Can I do that in line of the base is the question. I could have sworn I've done this before. No, that definitely wouldn't be the right. I mean, I think I might be able to do vertices equals this. Just have a default initializer in here, or like a too many initializer values. Really? Man, I was hoping that this would be like a cool way to get this done that would be nice and easy instead of the vertices 0, la la la, like initialize array in constructor C++. Oh, I could have sworn there was a way to do this. In the constructor initializer, can I do something like this? Grumble, grumble, grumble. It doesn't look like that is an option. Yeah, it just doesn't look like it's an option. That's too bad. That really is. I'll have to come up with something. Look around a little bit more after the stream, maybe. But for now, cells. Because I do it twice, too. That's the other thing. It's like... I was kind of hoping, since I do it multiple times, that this would be something that's nice and easy to set up, but apparently not. Who'da thunk? Okay. Cell edge. Everything does its basic job. What am I missing, or is there anything... I guess... Okay. Cell can go through. It creates its vertices. It creates its edges. We need to make sure it fills everything else in. For example, does cell fill in its own center? Yes. Looks like it does. Does it fill in its type or elevation? No. That's something we still have to get to. But it looks like we're generating the groups and the edges and the vertices okay. Will you run? More than 2 cells are attempting to use a single edge. Ah. What? I could swear, like, it's funny, I've run into this before and my brain is just like, no, this isn't good, but I've seen this before as well. Ah, hi dog. Luckily he was down the hall, so even the barks are... Gosh, that's percussive though. So let's look at this edge real quick. This edge already, yeah, it already has 2 vertices. It goes from 0, 2.5 to 0.5, 2.5. And I am about to try and fill it in with what? I'm probably about to try and fill it in with 0, 2.5 and 0.5, 2.5. What? Am I looping over myself a second time? Or like too many times? Okay. Let's make this simple for us so that we can just step through it quickly and make sure it's doing everything right. And then we'll work our way back through it. Terrain size. When we say build terrain, this terrain size is coming through. So let's make this 2. Just to see. Right? Because it will push... Oh, it's actually... Oh, yeah. It's pushing range through. So let's make range 1. So it'll just create 4 cells of 1 size apiece. Create cell system. And each cell is going to be... Each group cell is going to be a cell. Just to make this the simplest case I can come up with. So when we create a cell group, let's see here. Here's our cell group constructor. So let's dump a breakpoint in here. Let's see where it goes. So here's our range from -1, -1 to 0, 0. Okay, those look like good values. Center should be -0.5 and -0.5. Good. The cell array is going to be size times resolution. It's going to be 1 by 1, which means 1 cell. Ooh. La La Land, do you have the... Oh, okay. I will change that in a second. Thank you very much, La La Land. That is fantastic. That is good news. Because otherwise, I would have been unhappily filling this in the slow way. And I'd really rather not be doing that. So, let's see here. Cell position. This is 0, so that's... This should honestly just be like minus 0.5, minus 0.5? Because it should be... Yeah, okay, no. So it's minus 1, minus 1. That's fine. So we create the cell, or we grab the cell pointer, and we call this initializer, which gives us the center of this cell, which is good. The cell vertices are already set up, and those are fine. Just double check them real quick in my head. Yeah, those look good. We then find the vertex. Now, none of these are going to exist the first time through, so I'm not even going to worry about it. And then we're going to go through and find that none of these edges exist. 3 and 4. Okay, that's fine. Actually, I'm just going to go through until we see the error, which I'm not seeing anymore. Crap. Okay, let's make the, not the train size larger. Let's make the resolution higher first. Oh wait, that's train size, isn't it? Nope, resolution. Okay, good. Turn up the resolution slightly, and I'm still not seeing it. Turn up the train size. Still not seeing it. Okay. Don't know. You should be an integer, now that I think about it. Oh, the silent sound, you got that right. Oh my gosh. See, I am so glad you guys are here to catch my back when I do stupid things, which I do very often. Okay, so the cell edge, first let's fix this. So it'll be vertices, V1, V2. Nice. And then cells should also do the same thing. C1, C2. And I can then pull these suckers out. Cannot specify explicit initializer for arrays. Really? Would this code work? It should. It looks like it should. But it looks like it's unhappy with it. La La Land, unfortunately, it seems like your code is not kicking in here. It doesn't like explicit initializers like that for arrays, which is bizarre, but I can kind of understand why. It keeps you from... this is using C++11. All of this stuff is in the right language. Or in the right subset of language, I guess I should say. Let's see here. The edges of the null pointer, or sorry, edges to null pointer. So when I create a cell edge, so these are getting initialized correctly. Hello.